Anything on this 1 week from today is okay. We do have some files on that day, so let's take a look at those files as well. Global variables are evil. Okay, I'm hoping that some of you remember that file name. I have not uploaded this file yet, so we'll go ahead and take a quick look. Well, this is after the modification. I overwrote the evil file with the fix of this program, so that's why I lost the original evil program. And let me take a look at the trace. This trace is actually done correctly. Okay, let's take a look. Okay, let me do this. So I'm going to do exactly the same trick, show both the code and the subroutine at the same time. How many people still kind of somewhat remember this particular topic? Sort of. Okay, very good. Okay, this is actually already fixed. I should have replaced it with another file name, but the class notes already has an example, of why it is bad to use global variables instead of local variables. So that part is already covered. I just want to make sure that people can see this part here. We have add3. Add3 has its own local variable I. We have add6. Add6 also has its own local variable I. The point of a local variable is twofold. One, the local variable of I of add6 is visible only within the pseudocode contained in the definition of add6. The local variable I of add3 is only visible within the context of the definition of add3. So just by that alone, that means there's no interference between add3 and add6 in this particular pseudocode, because the two i's are actually distinct. They refer to different variables. That's the first part about a local variable being quote-unquote local. It is local to the subroutine in terms of the scope. The scope refers to who can see that variable. But the second part about the localness of a local variable has to do with when does that variable start to exist. The local variable I of subroutine 6 does not start to exist until row 4 of the trace, until we invoke the subroutine from outside of the subroutine. Okay, until that point, let me just show you what line 18 is. This is line 18. Line 18 is outside of the definition of the subroutine. On line 18, we invoke add6. As we invoke the subroutine add6, we allocate a column for return line number, just like before. But now that we have local variables, we also allocate a column for the local variable I. So that means the local variable I of add6 does not start to exist until add6 is actually invoked. Okay? Is that okay so far? Because this controls what we call the lifespan of a local variable. When does it start to exist and when does it die? In this case, column E, which is the local variable I of add6, it dies. Well, let's see. I did not finish the trace because it was too long. But it dies when the subroutine add6 returns. In other words, when we deallocate the column of the return line number, we also deallocate the column that we allocate for I. And the same thing applies to the local variable I of add3. Column G, the I of column G refers to the local variable I of add3. It starts to exist when we invoke on line 12, and it ceases to exist on line 7, because line 7 is the last line of the subroutine add3. Are there any questions at this point about local variables? Go ahead.
Okay, when you made the local variable, you gave it its own column.
Yes.
But it's just temporary, right? It doesn't affect anything.
It is temporary.
Okay. So how do we know which? Because you have local I twice.
Mm-hmm.
So it's the same variable by the same name. How do you know which is?
By the line number. If the line number says that you are inside add6, then you're using the local variable I of add6. Now there's one other easy way to tell which I you're using, because you're always using the I that is the latest definition. The most recently defined I is always the one that you're going to use.
Okay.
If you look at the columns kind of grow out like this. It grows all the way to the right-hand side. The rightmost columns basically becomes the context where you will use the variables to run the code. Are we okay so far with this program? Okay. If we're okay with this program, we're going to write something that's new for today. Have we talked about factorial in this class? Yep, okay. So what we'll do is we'll define a subroutine to do exactly that. We'll define a subroutine to calculate factorial. And this time we'll make use of local variables. I'll have one single local variable called x. The first thing I do before I do anything else is to say make a copy of the global variable n and make it x. And I lost my configuration, so I have to redo all the other options here. Replacement table, but everything else I have to turn off. So the first thing I do is to make a copy of the global variable, and the local copy is called x. And then I make, I have a conditional statement. I say if x is less than or equal to 1, then the result is going to be 1. I will fix the indentation later, and also bump up the font size so it will be easier to read like that. Now the else case is more complicated because in the else case I have to perform recursion. The first thing I do is I will say n gets n minus 1, and then I will invoke factorial again. The result will be result times x, and if and define sub, and here is the main part of the program, which is outside of any subroutine definition. And let's say that n gets 3 to begin with, and then we invoke the subroutine called factorial. And now I have to fix all the indentations. Oops. There we go. Are there any questions about the pseudocode itself? No questions? I think I'll still use a line number column here. It looks kind of redundant until you print it out. Okay, because when you look at this, this looks kind of redundant because the row numbers are exactly the number on column A. When you look at it from the spreadsheet, everything looks fine. It looks redundant, but when you print it out, the column number does not get printed out unless you tell the spreadsheet program to also print out the column number and the row numbers, or the column names and the row numbers.
In the previous program, you did not give the line saying local I.
Yeah,
numbers?
well that's because I inserted that line later on, and I didn't bother to give it a line number.
Oh,
because
okay, so in actuality it deserves one.
It doesn't matter because we're not going to step on that line. It's just easier for me to give a line number to every single line.
Okay.
Okay. All right, so let's go ahead and trace this code and find out what it is going to do. I had a chance to talk to one of the professors who teaches cisp300, and he was kind of telling me how some students in his class were not doing so well or doing as well as he thought students should be doing at this point. And but most of the, so I asked him, what can I do in cisp300 to better prepare students for your class? And he said there's nothing. He said the people who are in trouble in his class were just being lazy and not doing the homework assignment or spending the time to actually do the homework assignments. So that's so that kind of tells you something about cisp360. You gotta allocate the time to do it. Okay, so we have comments, we have line number, and how many global variables do we have? We have more than one. We have n and we have r. They are both global variables. And global variables have an quote-unquote infinite lifespan. In other words, they exist as soon as the program starts to run, and they do not die until the program itself has terminated. So that's why global variables are said to have quote-unquote infinite lifespan from the perspective of the lifespan of a program. Okay, the first line we execute, well, let's go ahead and do the precondition anyway. Let's just say that we don't know anything about n or r, which is fine, because on line 13 we initialize n to 3, and then on line 14 we invoke the subroutine called Factorial. So the mechanism has two phases, or two steps. The first step is to allocate a new column, in this case column E, and we have to remember where we're supposed to go to when we're all done. What should I put here? Post, exactly, because line 14 is already the last line of the pseudocode, so we have to write down post to indicate that when we are done with the subroutine, the entire program is done as well. And then what do we need to do? Remember, we have a single local variable x. What do? We have to allocate another column for x. And because it is a local variable, it starts with a value, but we don't know what that value is. Now, it is very, very important for you guys to remember that x as a local variable starts with an unknown value. Okay? We know that it has a value of some kind, we just don't know what it is. In other words, do not count on x always starting with a value of 0 or some other known value. It is unknown. Now, this part depends on the programming language. In cisp360, it is definitely an unknown. In Visual Basic, it is actually always 0. But which assumption would you make not knowing? Let's say you're not familiar with a particular programming language. Which assumption are you going to make?
Undefined.
Exactly, because if you think it is always undefined and always make it initialized later on, then in the worst case, you're just wasting time to reinitialize something that already has a known value. On the other hand, if you assume that it always starts with a value that is 0, but it turns out not to be the case, then you can be in big trouble, because now you're working with a value that is not what you think it is. Now that we are done setting up column E and column F, which are on a per invocation basis, we go start on the first line of the pseudocode of the subroutine. Factorial starts on line 3 because line 1 and line 2 are not really something that we can execute, but line 3 is something that we can do. On line 3, it is an assignment statement. The right-hand side is just n. N has a value of 3. We copy that to x, so x now also has a value of 3. Then we go to line 4. We evaluate the condition x is less than or equal to 1 is false, because we have 3 as x, 3 is less than or equal to 1 is false. We have to go to the else branch, which starts on line 7. Line 7 doesn't do anything that exciting either. All it is going to do is to decrement the value of n. N goes from 3 to 2. Then we go to line 8. Line 8 is invoking Factorial again. In this sense, it is kind of like the function call, or the procedure called, I keep using those terms that we have not mentioned in this class. It goes back to the subroutine called